Hi everyone, we all know Yann LeCun, a very famous AI scientist, previously at Meta and now running his own startup. So Yann LeCun kept on saying, and he still says, that LLMs will hit a wall. LLMs cannot even help you produce cat level intelligence. So if you think about it, even a cat has a biological brain, and the biological brain of a cat has evolved in such a way that it understands the real physics behind the universe, right? It understands the physical and spatial structure of all the objects in the universe, right? So if a mouse is going straight running under the cabinet, the cat will know that the mouse is still there, right? The mouse has not surpassed or bypassed the wall, right? So this is what he defines cat intelligence. So cat intelligence is like a benchmark in AI, right? So even to hit a cat intelligence, we will need to think beyond large language models, right? Now we have something to introduce today, especially in this lecture, which is known as Project Genie. So Project Genie is a great initiative and a research project by Google DeepMind. It has not been productionized for all consumers yet, but just imagine if you could convert a still picture, a still image of maybe a scenery into a video. Now you could play interactively within that video, right? So it's like you are creating your own world, right? Now we are not essentially creating our own world, but we call them interactive environments, right? So Project Genie helps you convert your text, your linguistic prompt, and your visual prompts into an interactive environment, right? It's not only a simulation environment, but it's an interactive 3D environment. So Genie has evolved from Genie 1 to Genie 2 to Genie 3. So right now, Genie 3's capabilities, help you convert any picture, any visual along with a prompt into a 3D interactive environment where you can move objects, where you can maybe hover over a screen or hover over an object and navigate the whole scene or scenario. Now think about it. At MathWorks, I used to do scenario generation, scene generation. Now, what it meant was, since my team was working on self-driving cars and autonomous driving, we used to write motion planning algorithms for them, right? If we wanted to simulate and create a lot of scenes and scenarios, we had to do it manually and using simulation tools. And we had to write different algorithms to place different road objects, pedestrians, road signals, lane markings, lane objects, just to create a perfect scene. And we could only do it deterministic amount of times. But if we have these kind of models where we are able to generate not a video, not a photo, not something static, but dynamic, autoregressive, interactive environments where I can go and navigate in that environment, where I can go play in that environment, right? So it's like a video game. So we call it scenario generation. I can simulate all of my algorithms in that scenario. I can generate a scenario of Hyderabad and of Dubai, right? And I can run my motion planning algorithms and my cars in that scenario just to check how are they behaving without, taking them into a real environment. I can teach my agent. I can test my agent in that particular environment. Let's say the concept of reinforcement learning, where I can just deploy my agent in that environment to help it learn about the physical structure and the spatial structure of the universe, right? That agent is going to behave so much better, right? So that's what we did with AlphaFold also, right? So now Project Genie basically helps you create these kind of interactive environments. Now you use it for scenario generation, you use it for gameplays, and you use it for n number of, or you use it to produce a different model, you use it to produce an agent that understands the physical and spatial world. You maybe use it to create another world model, right, using those environments that understand the physical and spatial structure of the world, right? Now there is a lot of emphasis on understanding the physical and spatial structure of the world because we want to solve that in order to achieve AGI, right? There is a theory that you cannot achieve AGI only with LLM level intelligence, right? LLMs do not possess the understanding of physical and spatial structure. So now, does that mean Project Genie possesses that particular intelligence? No, not yet, right? Project Genie is a world model. It qualifies as a world model, but it is still probabilistic, right? It is still stochastic. It still behaves on the same principles as a large language model, right? So let's talk about it. Project Genie has been trained on a lot of YouTube videos and a lot of internet videos. I mean, a lot of data, that to video data on the internet, right? Now, Project Genie understands all of those videos and is able to create an interactive environment. If we try to mathematically position this particular creation, since it's a probabilistic model, we can describe the conditional probability behind Project Genie. So it would be something like this. What is the probability of a future frame xt plus 1 given the current frame and the action taken, right? It behaves on frames and actions. So given the current action and the current frame, what is the probability of next frame? Where let's say if we define xt plus 1 as the next frame to be generated, xt is the current frame and any at time instance t is an action, right? So this is how we would maybe define the conditional probability of Project Genie. So we know that Project Genie is a probabilistic model, but it is very close to today's world model. So today's world models are what is defined as Project Genie. Tomorrow's world model might have complete physical and spatial structure understanding of the whole universe, but today's world model, which is Project Genie, is still probabilistic and it is still stochastic. Even though it is probabilistic and stochastic, it still addresses a very famous problem, right? So there is a huge problem of data bottleneck in robotics. We have limited robotics data. We don't have a lot of simulation data for robotics and physical AI and embodied AI. So we need these interactive environments in order to, have a lot of training data for robotics and for physical AI systems. Now it offers a path towards AGI because it provides a training ground, right? Think of it as an environment provider. It provides a training ground where we can train different systems to have some common sense physics understanding. Now different systems can be your AI agents, right, or your new models, right? Now if we talk about Google's work in the Project Genie, so Genie has evolved from a very basic Genie 1 to Genie 3. So today we have Genie 3, which is the third version of Project Genie. So the first version of Genie was learning to create interactive environments, and it was trained on a lot of unlabeled data, a lot of unlabeled video data, right? We had a lot of YouTube gameplay and real world footage, so we trained Project Genie on that, right? But it had a problem, right? So let's imagine a frame 1, and frame 1 has evolved into frame 2. Now the series of actions that has undergone for frame 1 to evolve into frame 2, these series of actions needed to be understood and needed to be predicted, right? So Project Genie, the Genie 1 addressed this issue, and Genie 1 was mostly doing 2D environment creations. It did not do very photorealistic 3D environment creations. It was only doing 2D, but the good thing was that it was able to predict the latent state between a frame 1 and frame 2, the latent action specifically, and it had an autoregressive nature. So just like large language models have an autoregressive nature, so it also had an autoregressive nature where it could go in loop to generate the next frame and the next frame and the next frame given the previous action and the latent action, right? So given the previous frame and the latent action, to be precise, right? So then we came on to something known as Genie 2. Now Genie 2 was all about scale, right? We scaled Genie 1 to be able to, generate 3D interactive environments, right? We could do more realistic scenes. We could do realistic scenes along with animated scenes with Genie 2. And Genie 2 solved the problem of, solved all the problems that Genie 1 was facing, but it was still not sufficient enough. That's why we had to evolve into something like Genie 3. Genie 3 is what represents today's idea of world models, today's idea of world modeling, right? It has real-time interactivity and it can produce very high resolution, and it operates at 24 frames per second at 720 pixels of resolution, right? So 720 pixels is still high for an interactive environment with respect to today's benchmark. So what did it majorly solve, right? So some things that are worth noting. So long horizon consistency. The major feature in video generation models like like VO3 and even the Chinese open source models is drifting, right? So it's basically, so drifting is a problem where the environment is changing randomly, arbitrarily over time, right? So it's like Yann LeCun used to say that errors drift over time in LLMs, errors compound over time in LLMs, right? That's why LLMs are doomed. So same problem with video generation, that the environment changes arbitrarily over time, right? So it solved long horizon consistency. It solved this problem. So Genie has a memory mechanism to solve this. So what it basically does is it is able to recall the previous environment and actions for up to 1 minute, and it is able to store them, right? So it has a one minute time window, but it is still able to recall and store it. Now, one of the best things that I liked that it solved was promptable world events. So, how to think about it? Now, just imagine that there is an interactive environment and you can write a prompt. Let's say you made a city of your own. You made a Dubai-like city of your own, and you wrote a prompt while interacting with that city that make it rain, right? Or spawn on a car, right? So, it kind of solved that feature also. Okay. Now, the third thing is, I mean, this is not something which is fully solved, but it is still a technical advancement. The third feature. So after long horizon planning and after promptable world events, the third technical advancement that I would note or that I would recommend is, which it's not fully solved, but it is still an advancement based on the previous models, which is the idea of neural physics engine, right? So the model does not uses a traditional physics engine, right? So that's why we don't call it a world foundational model or foundational world model yet, right? But it uses physics based, it simulates physics based on its training data. It has seen a lot of training data around real world videos and on the internet and on YouTube gameplays, right? So it tries to simulate physics based on the training data, and it allows for simulation of complex fluids, gravity, soft bodies, and terrain, right? So that's why it is able to somehow understand physics in the common sense physics, but not completely just like a full world model would do. Now, DeepMind is super clever and super intelligent, right? Genie is not alone. Genie does not act alone. It's the whole ecosystem. They've got the best video generation model. They've got the best image generation model, which is Nano Banana Pro, which even powers the video generation model. They've got the best reasoning agent. Let's call it Gemini, right? So now think about this ecosystem where they have Chrome to perform agentic capabilities on the web. Now they have Nano Banana Pro to create very realistic static images, very realistic static objects in those interactive environments. And they have Gemini. Now, what would Gemini do? Gemini can break a user prompt into sub problems that are very much quantifiable and understandable for different models like Nano Banana Pro and Genie, right? So Gemini is doing its own part where it's trying to break down the user prompt into genuinely executable stuff for Nano Banana Pro and for Genie. Genie is trying to handle dynamics, it is trying to handle movement, physics, and environment, and Nano Banana Pro is helping us give texture, the visual quality texture to those environment, right? So it's doing the texture mapping for the generated worlds. It is helping us produce high quality images, although they are static, but we need certain high quality images to be embedded in these kind of environments. And on top of that, Chrome tools and their Chrome environment is helping us or helping this whole ecosystem have agentic capabilities and browse and control the whole web. So this is the whole overall Project Genie ecosystem, and this is a great advancement and a path towards AGI because it solves a couple of bottlenecks, especially in robotics and the training data for robotics, and it gives us a paradigm, be able to think about world models and what can potentially be done if we have a full-fledged foundational world model. Thank you. Cheers. See you in the next videos.